Have you ever wondered why your smartphone screen lights up instantly when you touch it, or how your GPS knows exactly where you are within a few feet? What if I told you that the same bizarre physics that makes particles exist in multiple places at once is quietly running your entire digital life? Tonight, we're diving into the hidden quantum world that powers everything from your morning coffee maker to the satellites orbiting above your head. But before we begin our journey into the quantum realm, I'd love to welcome you fellow weary researchers and get to know where in the world you're listening from and what time it is in your corner of the universe. Each new video brings more comments that I get to see where you're tuning in from, like Arizona and Alabama to Quebec and Montreal. Drop a comment and let me know. I genuinely love seeing how this little community of curious minds spans across the globe. If you find these explorations into the hidden workings of our world as fascinating as I do, I'd be incredibly grateful if you gave this video a like and hit that subscribe button. It truly helps more curious souls discover these deep dives into the science that shapes our reality. And who knows, by the end of this video, you might never look at your everyday devices the same way again. Now, I'll do my best to keep things engaging without making your brain hurt too much. But if you do find yourself lying awake tonight thinking about quantum tunneling and wave functions, well, at least you'll understand why your computer works the way it does. So settle in, get comfortable, and let's explore how the strangest physics in the universe quietly powers your world. Right now, as you're watching this video, something absolutely extraordinary is happening inside the device you're using. Deep within the silicon heart of your smartphone, tablet, or computer, electrons are doing something that should be impossible according to the everyday physics we learned in school. They're jumping through barriers that they don't have enough energy to cross, teleporting across gaps that should stop them cold, and behaving in ways that would make even the most creative science fiction writer pause and say, "That's a bit much, isn't it?" This impossible behaviour isn't a glitch in the Matrix. It's quantum mechanics in action, and it's the reason you can binge-watch videos, send messages across the planet in milliseconds, and carry more computing power in your pocket than entire governments had access to just a few decades ago. But let's start with something that might surprise you. The quantum world isn't some distant theoretical realm that only matters to physicists in lab coats. It's happening right here, right now, in ways that directly impact your daily life. Every LED light that illuminates your home, every solar panel that captures energy from the sun, every MRI scan that peers inside the human body, and yes, every digital device you've ever touched, they all depend on quantum mechanical effects to function. The story begins with something called quantum tunneling, and it's probably the most mind-bending phenomenon you'll encounter today. Imagine trying to ride your bicycle up and over a mountain, but you don't have enough energy to reach the peak. In our everyday world, you'd simply roll backward down the hill, defeated by gravity and physics. But in the quantum world, something magical happens. You might just find yourself on the other side of the mountain, having somehow passed through solid rock without actually climbing over it. This isn't a metaphor or an analogy. This is literally what electrons do billions of times per second inside your electronic devices. They encounter energy barriers that should stop them, and yet they appear on the other side as if those barriers didn't exist. It's like watching someone walk through a brick wall, except it's happening constantly at the atomic scale, and it's absolutely essential for modern technology to work. Inside every computer processor, memory chip, and smartphone, there are structures called transistors, tiny electronic switches that can be turned on or off to represent the ones and zeros that make up digital information. These transistors have become incredibly small over the decades, so small that they're now approaching the scale where quantum effects become unavoidable. Modern transistors are only a few atoms thick in some dimensions, which means electrons don't behave like tiny billiard balls following predictable paths. Instead, they behave like quantum particles, with all the strange properties that entails. When engineers first started making transistors this small, they encountered a problem. Electrons were tunneling through barriers they weren't supposed to cross, causing what's called leakage current. It was like trying to build a dam out of material that water could mysteriously pass through. Initially, this seemed like a serious obstacle to making computers smaller and faster. But here's where human ingenuity meets quantum weirdness in the most beautiful way. Instead of fighting quantum tunneling, engineers learned to harness it. They designed new types of transistors that actually rely on quantum tunneling to operate. Flash memory, the technology that stores photos on your phone and documents on your computer, works by trapping electrons in quantum wells and then using controlled tunneling to read and write information. Think about that for a moment. Every selfie on your phone, every song in your music library, every app you've downloaded, they're all stored using a technology that depends on electrons doing something that would be impossible in the everyday world we experience. Your vacation photos exist because electrons can tunnel through energy barriers that should stop them cold. But quantum tunneling is just the beginning. There's another quantum phenomenon that's even more essential to modern life, though it often goes unnoticed: the photoelectric effect. This is the quantum mechanical process that explains how light can knock electrons loose from materials, and it's the foundation for an enormous range of technologies that surround us every day. Every time you use a digital camera, whether it's the sophisticated sensor in a professional photographer's equipment or the tiny camera in your smartphone, you're witnessing the photoelectric effect in action. When light hits the camera's sensor, individual photons, those fundamental particles of light, strike electrons in the sensor material and transfer their energy to them. If a photon has enough energy, it can knock an electron completely free, creating an electrical signal that can be measured and converted into digital information. This isn't just how cameras work, it's how solar panels generate electricity from sunlight, how automatic doors know when someone is approaching, how smoke detectors sense particles in the air, and how the scanning technology at grocery store checkouts reads barcodes. The photoelectric effect is so fundamental to modern technology that it's hard to imagine our world without it. Albert Einstein won the Nobel Prize in Physics, not for his famous theory of relativity, but for explaining the photoelectric effect in quantum terms. He realized that light doesn't just behave like a wave, as scientists had believed for centuries, but also like a stream of particles, photons, each carrying a specific amount of energy. This wave-particle duality of light is one of the core principles of quantum mechanics, and it's actively at work every time you take a photo, charge your phone with a solar charger, or walk through an automatic doorway. But perhaps the most ubiquitous quantum technology in our daily lives is the laser, though most people don't realize just how quantum mechanical lasers really are. The word laser stands for light amplification by stimulated emission of radiation, and that stimulated emission part is pure quantum mechanics in action. Inside a laser, atoms are excited to higher energy levels, creating what physicists call a population inversion, a situation where more atoms are in excited states than in their ground states. When one excited atom spontaneously drops back to a lower energy level and emits a photon, something remarkable happens. That photon can stimulate other excited atoms to emit identical photons, same energy, same direction, same phase. It's like a quantum domino effect, where one photon triggers the emission of many more identical photons. This process creates coherent light where all the photons are marching in perfect synchronization, like a precisely choreographed army of light particles. This coherent light has properties that make it incredibly useful for everything from reading the data on DVDs and Blu-ray discs to performing delicate eye surgery, cutting through steel, measuring distances with incredible precision, and transmitting information through fiber optic cables. Every barcode scanner at the grocery store uses a laser to read product information. The laser printer sitting in your office creates text and images by using laser light to precisely control where toner adheres to paper. The fiber optic cables that carry internet traffic around the world use laser light to transmit data at nearly the speed of light across vast distances. Even many of the entertainment systems in our homes, DVD players, Blu-ray players, gaming consoles, use lasers to read the microscopic pits and lands on optical discs that encode movies, music, and games. What's truly remarkable is that all of these applications depend on the quantum mechanical property of stimulated emission. Without this fundamentally quantum process, we wouldn't have the precision manufacturing, telecommunications, infrastructure, medical procedures, or entertainment technologies that define modern life. Now let's talk about something that might seem completely unrelated to quantum mechanics, but is actually one of its most important everyday applications: the Global Positioning System, or GPS. Every time you use navigation on your phone, call for a rideshare, or check in at a location on social media, you're relying on a technology that requires quantum mechanical precision to function properly. GPS works by measuring the time it takes for signals to travel from satellites orbiting Earth to your device. By comparing signals from multiple satellites, your phone can triangulate your position with remarkable accuracy. But here's the quantum connection. Those timing measurements need to be incredibly precise. We're talking about nanoseconds, billionths of a second. Even tiny errors in timing would cause GPS to be off by hundreds of meters, making it essentially useless for navigation. The atomic clocks aboard GPS satellites achieve this incredible precision by using the quantum mechanical properties of atoms. These clocks measure time based on the natural vibration frequency of cesium atoms, specifically the frequency at which electrons in cesium atoms oscillate between different energy levels. This frequency is so stable and precise that it serves as nature's own metronome, keeping time with an accuracy that's almost incomprehensible. But there's more. Einstein's theories of relativity, which are intimately connected to quantum mechanics, predict that time actually runs slightly differently for the fast-moving satellites compared to receivers on Earth's surface. Without correcting for these relativistic effects, GPS would accumulate errors of several kilometers per day. The fact that your phone can tell you your location within a few meters is a testament to our understanding of both quantum mechanics and relativity. Every time you successfully navigate to a new restaurant, find your parked car, or share your location with friends, you're benefiting from quantum mechanical precision combined with relativistic corrections. It's a beautiful example of how the most abstract and seemingly impractical physics can become essential for everyday convenience. But the quantum mechanical effects in your everyday devices go far deeper than most people realize. Right now, as you're reading this, the very screen you're looking at is performing what can only be described as electronic magic, and it all comes down to something called quantum confinement. Modern LED displays, whether they're in your smartphone, your television, or the digital billboard you passed on your way home today, work because engineers have learned to trap electrons and holes, the absence of electrons, in incredibly tiny spaces. When I say tiny, I mean structures that are only a few nanometers across, so small that you could fit millions of them across the width of a human hair. When electrons and holes are confined to these quantum scale dimensions, something fascinating happens. The energy levels they can occupy become quantized, meaning they can only exist at very specific energy values, like rungs on a ladder rather than points on a smooth ramp. When an electron drops from a higher energy level to a lower one, it releases a photon of light with a very specific color determined by that energy difference. This is how manufacturers can create displays that produce incredibly pure, vibrant colors. By precisely controlling the size of these quantum structures, they can tune the exact wavelength of light that's emitted. Want a perfect red? Engineer quantum dots of one size. Need a brilliant blue? Make them slightly smaller. This level of control over color and brightness was simply impossible with older display technologies. But quantum confinement isn't just making your Netflix binges more visually appealing. it's also revolutionizing how we generate and store energy. Those increasingly efficient solar panels you see sprouting up on rooftops everywhere. Many of them use quantum dots to capture and convert sunlight more effectively than traditional silicon cells. Here's where it gets really interesting. Normal solar cells can only efficiently capture photons with energies very close to their band gap, the minimum energy needed to knock an electron free. Photons with too little energy pass right through, while photons with too much energy waste their excess energy as heat. But quantum dots can be engineered to have multiple energy levels, allowing them to capture a much broader spectrum of sunlight and convert it to electricity with unprecedented efficiency. Scientists are even working on quantum dot solar cells that could theoretically exceed the fundamental efficiency limits of traditional solar technology. Imagine solar panels that could generate electricity not just from visible light, but from infrared radiation, heat that's normally wasted. Your roof could be generating power even on cloudy days, even at night, just from the ambient thermal energy in the environment. And then there's the quantum mechanics happening inside every battery that powers our portable world. Whether it's the lithium-ion battery in your smartphone or the massive battery pack in an electric vehicle, the fundamental process of storing and releasing electrical energy depends on quantum mechanical effects at the atomic level. When you charge your phone, you're forcing lithium ions to move from one electrode to another, where they're stored in the crystalline structure of the electrode material. This process involves quantum tunneling as ions navigate through the atomic lattice, and the efficiency of this process determines how quickly your battery charges, how long it lasts, and how many times you can recharge it before it degrades. Battery researchers are now designing new electrode materials at the quantum level, engineering the precise arrangement of atoms to create pathways that ions can traverse more easily. Some experimental batteries use quantum effects to store charge in ways that could dramatically increase energy density. Imagine a smartphone battery that lasts a week on a single charge, or an electric car that can drive 1,000 miles before needing to plug in. But perhaps the most mind-bending quantum application that's already touching your daily life is quantum cryptography and quantum secure communications. While full-scale quantum computers are still in development, quantum effects are already being used to create communication systems that are theoretically unbreakable. The principle is elegantly simple, yet profoundly quantum. When you measure a quantum system, you inevitably disturb it. This isn't a limitation of our measuring instruments. It's a fundamental feature of quantum mechanics. Any attempt to eavesdrop on a quantum encrypted message would necessarily disturb the quantum states carrying the information, immediately alerting the sender and receiver that someone is trying to intercept their communication. Banks and government agencies are already using quantum key distribution systems to secure their most sensitive communications. The quantum states of individual photons carry encryption keys across fiber optic networks, and any attempt to intercept these keys would be immediately detectable. It's like having a burglar alarm that's built into the very fabric of reality. This technology is gradually making its way into commercial applications. Some companies are already offering quantum-secured communication services for businesses that need absolute privacy. In the not-too-distant future, you might be making phone calls and sending messages that are protected by the fundamental laws of quantum mechanics themselves. But we don't need to wait for the future to see quantum mechanics changing how we interact with information. Machine learning and artificial intelligence, the technologies that power everything from your phone's voice assistant to the recommendation algorithms that suggest what to watch next, are increasingly being enhanced by quantum-inspired computing techniques. Traditional computers process information using bits that are either 0 or 1, on or off. But quantum systems can exist in superposition, simultaneously being in multiple states at once. While we can't yet build large-scale quantum computers for everyday use, computer scientists have developed algorithms inspired by quantum mechanics that can solve certain types of problems much more efficiently than traditional methods. When your phone's camera automatically recognizes faces in photos, when your music streaming service suggests songs you might like, when your GPS calculates the fastest route through traffic, these applications are increasingly using quantum-inspired algorithms that can process vast amounts of information in ways that mirror how quantum systems explore multiple possibilities simultaneously. The quantum revolution in computing is happening gradually, but its effects are becoming more noticeable every day. The artificial intelligence models that can generate realistic images from text descriptions, translate languages in real time, or even write poetry and code. Many of these breakthrough capabilities emerge from computational techniques that borrow fundamental insights from quantum mechanics. And here's something that might blow your mind. Quantum effects are even at work in biological systems, including some that are essential for life on Earth. The process of photosynthesis, which converts sunlight into chemical energy in plants, appears to use quantum coherence to achieve its remarkable efficiency. When a photon hits a chlorophyll molecule in a leaf, it creates an excited state that needs to find its way to the reaction center, where the energy can be converted to chemical form. But the path through the complex molecular machinery of photosynthesis isn't straightforward. There are many possible routes, some more efficient than others. Recent research suggests that plant cells use quantum superposition to explore all possible pathways simultaneously, allowing the excited state to find the most efficient route to the reaction center. It's as if the energy can test every possible path at once and automatically choose the best one, achieving an efficiency that would be impossible with purely classical physics. This quantum-enhanced photosynthesis is one reason why plants are so remarkably good at capturing and using solar energy. Scientists are now trying to reverse engineer these quantum biological processes to create artificial photosynthetic systems that could convert sunlight to fuel with unprecedented efficiency. But the quantum effects in biology don't stop there. Some researchers believe that quantum mechanics might play a role in how birds navigate during migration, how our sense of smell distinguishes between different molecules, and even how consciousness emerges from the electrical activity in our brains. The idea that quantum mechanics might be operating inside our own bodies, influencing how we perceive and interact with the world, is still controversial and actively debated. But the evidence is mounting that the boundary between the quantum world and the biological world isn't as clear-cut as we once thought. Every breath you take, every step you walk, every thought you think might be subtly influenced by quantum mechanical processes operating at the molecular level. The very fact that you're conscious and able to contemplate these ideas might itself depend on quantum effects in the neural networks of your brain. This brings us to something truly extraordinary. We're living through a moment in history when quantum mechanics is transitioning from a curious laboratory phenomenon to the foundation of entire industries. The smartphone in your pocket contains more quantum technology than most university physics labs had just a few decades ago. And this transformation is accelerating. Right now, in research labs around the world, scientists are developing quantum technologies that will make today's devices look primitive by comparison. Quantum sensors, so sensitive they can detect the gravitational waves from colliding black holes billions of light years away. Quantum computers that could simulate molecular interactions with perfect accuracy, revolutionizing everything from drug discovery to materials science. Quantum networks that could connect the entire planet in a web of unhackable communication. But here's what's truly remarkable about this quantum revolution. It's not happening in some distant future. It's happening now, quietly, invisibly, in the devices and systems you use every single day. That gentle buzz of your phone's vibration motor, it's controlled by quantum mechanical effects in the accelerometer chips that detect motion. The GPS in your car that guides you through rush hour traffic? It depends on quantum atomic clocks, maintaining precision to within billionths of a second. Even something as simple as the LED light bulb illuminating your room right now is a quantum device. Inside that bulb, electrons are making quantum leaps between energy levels, literally jumping from one quantum state to another and releasing photons in the process. The color of the light, its efficiency, its longevity, all of these properties emerge from quantum mechanical processes happening trillions of times per second. Let's take a moment to appreciate just how extraordinary this really is. The same physics that baffled Einstein and sparked heated debates among the greatest minds of the 20th century is now so well understood that we've turned it into mass-produced consumer products. We've taken the weirdest, most counterintuitive aspects of reality and made them work for us in ways that would seem like magic to someone from just a century ago. Consider the touchscreen you might be using to control this video right now. When you tap the screen, you're not just pressing a button, you're changing the electrical properties of a quantum system. Modern touchscreens work by detecting tiny changes in capacitance, the ability to store electrical charge. Your finger, being slightly conductive, creates a disturbance in the electric field at the quantum level that the screen's sensors can detect and interpret. But the quantum effects go deeper than just detection. The transistors that process your touch input are operating in regimes where electrons exist in quantum superposition states until the moment they're measured. The memory chips that store the response to your touch use quantum tunneling to write and erase information. The display that shows the result uses quantum confinement effects to generate the precise colors you see. Every interaction with your device is actually an interaction with a carefully orchestrated quantum system. You're not just a user of technology, you're a participant in quantum mechanical processes, influencing the behavior of electrons and photons through your choices and actions. This intimate connection between human behavior and quantum physics becomes even more profound when you consider how quantum effects influence the very chemistry of life. The food you eat, the air you breathe, the water you drink, all of these interact with your body through chemical processes that are fundamentally quantum mechanical in nature. When you smell a flower, molecules from the flower enter your nose and bind to receptor proteins in ways that depend on their quantum mechanical shapes and properties. The lock and key mechanism of molecular recognition that allows you to distinguish between the scent of roses and the scent of coffee is a quantum process. The very fact that different molecules have different smells is a consequence of how their electron clouds interact with the quantum states of your olfactory receptors. Similarly, when you taste food, your taste buds are detecting quantum properties of molecules, their shape, their charge distribution, their ability to interact with specific receptor sites. The sweetness of sugar, the saltiness of salt, the umami of mushrooms, these are all quantum mechanical phenomena that we experience as conscious sensations. Even the colors you see are quantum mechanical. When light hits your retina, individual photons interact with rhodopsin molecules in your eye through a process that depends on quantum transitions between energy levels. The fact that you can distinguish between red and blue, that you can see a sunset or appreciate the colors in a painting, emerges from quantum mechanical processes in the molecules of your visual system. This means that every moment of conscious experience, every sight, sound, smell, taste, and touch involves quantum mechanics at the most fundamental level. You're not separate from the quantum world. You're immersed in it, shaped by it, defined by it, in ways that science is only beginning to understand. But let's bring this back to the technology that surrounds us, because the quantum revolution is far from over. In fact, we're standing at the threshold of what many scientists believe will be the second quantum revolution, a period when we move beyond simply using quantum effects in our devices to actively manipulating and controlling quantum systems for entirely new purposes. The first quantum revolution gave us transistors, lasers, and integrated circuits, the building blocks of the digital age. The second quantum revolution promises quantum computers that could solve problems beyond the reach of any classical computer, quantum sensors that could detect dark matter or peer inside the human body with unprecedented precision, and quantum communication networks that could transform how we share information across the globe. Some of these technologies are already beginning to emerge from research labs and enter the real world. Quantum sensors are being used to search for underground oil deposits, to detect submarines lurking beneath the ocean surface, and to monitor brain activity in ways that could revolutionize our understanding of consciousness and mental illness. Quantum-enhanced medical imaging is making it possible to see inside the human body with resolution and sensitivity that was unimaginable just a few years ago. Doctors can now detect cancer cells when tumors are still microscopic, track the movement of individual molecules through living tissue, and monitor the effectiveness of treatments at the cellular level. In the world of cybersecurity, quantum technologies are creating both opportunities and challenges. While quantum computers could potentially break many of the encryption systems that currently protect our digital lives, quantum cryptography offers the promise of communication that is secured by the laws of physics themselves. It's an arms race between quantum codebreakers and quantum codemakers, with the security of our digital future hanging in the balance. But perhaps the most exciting frontier is quantum artificial intelligence, the merger of quantum computing with machine learning algorithms. Traditional AI systems learn by processing vast amounts of data and finding patterns, but they're limited by the sequential nature of classical computation. Quantum AI systems could explore multiple solutions simultaneously, learning and adapting in ways that mirror the superposition and entanglement effects that define quantum mechanics. Imagine an AI assistant that doesn't just respond to your questions, but actually exists in a superposition of all possible responses until you interact with it, collapsing the quantum state into the most helpful and relevant answer. Picture recommendation systems that can simultaneously consider all possible preferences and outcomes, delivering suggestions that are perfectly tailored to your unique combination of interests and circumstances. This isn't science fiction, it's the logical next step in the evolution of both quantum technology and artificial intelligence. Companies like IBM, Google, and Microsoft are already building quantum computers specifically designed for machine learning applications. Universities around the world are training a new generation of quantum engineers and programmers who will build the quantum-enhanced technologies of tomorrow. And here's what's truly remarkable. Just as the first quantum revolution transformed our world in ways that the pioneers of quantum mechanics never could have predicted, the second quantum revolution will likely surprise us with applications and capabilities that we can't even imagine today. The scientists who first discovered quantum tunneling in the 1920s had no idea they were laying the groundwork for the smartphone you carry in your pocket. The researchers who developed the theoretical foundations of quantum mechanics couldn't have foreseen GPS navigation, LED lighting, or MRI machines. Similarly, the quantum technologies being developed today will probably find their most important applications in areas we haven't even thought of yet. But one thing is certain: quantum mechanics will continue to be woven more and more deeply into the fabric of our daily lives. The line between the quantum world and the everyday world isn't just blurring, it's disappearing entirely. We're not just using quantum technology, we're becoming quantum-enhanced beings, our capabilities extended and amplified by our partnership with quantum systems. Every time you make a phone call, take a photograph, check your location, or simply turn on a light, you're participating in this quantum dance. You're collaborating with electrons that tunnel through barriers, photons that exist in superposition states, and atoms that vibrate with quantum precision. You're not just the observer of the quantum world, you're an active participant in it, and this participation is becoming more intimate and more profound with each passing year. The quantum sensors in your fitness tracker monitor your heart rate by detecting quantum changes in blood flow. The quantum-enhanced cameras in your phone capture light with sensitivity that rivals the human eye. The quantum processors in your devices respond to your thoughts and intentions with speed and precision that makes your smartphone feel like an extension of your own mind. We're living through a transformation that's as profound as the transition from the mechanical age to the electronic age, except this time we're moving from the electronic age to the quantum age. And unlike previous technological revolutions that took decades or centuries to unfold, the quantum revolution is happening at the speed of light, literally. The photons carrying your internet traffic, the electrons tunneling through your processor, the quantum states encoding your digital memories, they're all operating at speeds that approach the fundamental limits imposed by the laws of physics. We're not just building faster technology, we're approaching the ultimate speed limits of information processing and communication. This means that the quantum devices of tomorrow won't just be more powerful than today's technology, they'll be operating at the very edge of what's physically possible. We're approaching a future where our tools and technologies will be limited not by human engineering constraints, but by the fundamental structure of reality itself. And that future is arriving faster than you might think. The quantum smartphone in your pocket 5 years from now might be able to run quantum algorithms that solve complex optimization problems in real time, helping you make better decisions by exploring all possible outcomes simultaneously. Your quantum-enhanced smart home might use quantum sensors to monitor your health and environment with precision that makes today's fitness trackers look primitive. The quantum internet of the near future could connect your devices through quantum entanglement, creating communication channels that are not just faster and more secure than anything we have today, but that operate according to principles that seem to transcend the normal limitations of space and time. But here's perhaps the most mind-bending aspect of our quantum future. As quantum technologies become more sophisticated and more integrated into our daily lives, the boundary between technology and biology, between artificial and natural, between human and quantum, will continue to blur. We're already seeing the first hints of this convergence. Quantum sensors can detect neural activity with unprecedented precision, potentially allowing direct interfaces between human thoughts and quantum computers. Quantum-enhanced drug discovery is leading to medications that work by influencing quantum processes in our cells. Quantum biology research is revealing that many of the processes that keep us alive, from photosynthesis to cellular respiration to neural computation, may themselves be quantum phenomena. This suggests a future where the line between human consciousness and quantum computation becomes increasingly blurred. Imagine neural implants that use quantum entanglement to connect your thoughts directly to the global information network, or quantum-enhanced prosthetics that respond to your intentions faster than your own nervous system could transmit signals. But before we get too far ahead of ourselves, let's pause and consider something truly remarkable about this moment in history. You're living at a unique point in time when quantum mechanics is transitioning from the realm of abstract physics into the foundation of human civilization. Every generation experiences technological change, but rarely does a generation witness the emergence of entirely new laws of nature becoming the basis for everyday life. Think about your grandparents, who might have grown up in a world where the most advanced technology was a radio that could pick up signals from a few hundred miles away. Now you carry a device that can instantly communicate with anyone on the planet, access the sum total of human knowledge, and perform calculations that would have taken room-sized computers decades to complete. That transformation happened because we learned to harness quantum mechanical effects that were completely unknown to previous generations. But here's what makes this even more extraordinary. We're not just using quantum mechanics as a tool, we're becoming quantum ourselves. Every time you interact with your smartphone, you're entangling your intentions with quantum states inside the device. When you take a photo, you're collaborating with photons that have traveled millions of miles from the sun, through the atmosphere, off your subject, and into quantum sensors that convert light into digital information. Your brain processes this visual information through neural networks that may themselves operate using quantum effects. The memory of that photo gets stored in quantum devices, and when you share it with friends, it travels through fiber optic networks as quantum states of light, eventually reaching their devices, where quantum processes convert it back into images on their screens. The entire chain of experience, from perception to processing to storage to transmission to reception, involves quantum mechanics at every step. You're not just observing quantum effects, you're participating in them, shaping them, becoming part of the quantum fabric of reality itself. This participation goes deeper than most people realize. The atoms in your body are quantum mechanical objects. The chemical bonds that hold your cells together are quantum phenomena. The electrical signals in your nervous system depend on quantum tunneling effects. Even your thoughts and memories may emerge from quantum processes in the microtubules of your neurons. Some researchers propose that consciousness itself is a quantum phenomenon, that the unified experience of being you, the seamless integration of all your sensory inputs and memories into a single stream of awareness, requires the kind of instantaneous correlation across space that quantum entanglement provides. If this turns out to be true, then every moment of consciousness is itself a quantum measurement, collapsing probability waves into definite experiences. Your ability to make choices, to focus attention, to experience creativity and insight, all of these might depend on quantum effects operating in the warm, noisy environment of your brain. This would mean that the boundary between observer and observed, between mind and matter, between subjective experience and objective reality, is not as clear-cut as we once believed. You're not separate from the quantum world you're studying. You are the quantum world becoming aware of itself. But let's bring this cosmic perspective back down to Earth, because the quantum revolution happening around you right now has very practical implications for how you live, work, and connect with others. The quantum technologies being developed today will transform every aspect of human society within your lifetime. Consider healthcare, where quantum sensors are already enabling medical imaging with resolution that can detect diseases at the cellular level. Quantum-enhanced drug discovery is accelerating the development of personalized medications that work by targeting the specific quantum properties of diseased cells. Quantum computers could soon be designing new antibiotics, optimizing treatment protocols, and even modeling the quantum biology of aging itself. In transportation, quantum navigation systems could make GPS look primitive by comparison. Instead of relying on signals from satellites, quantum accelerometers and gyroscopes could provide navigation that works underground, underwater, or in deep space. Quantum-enhanced batteries could power electric vehicles for thousands of miles on a single charge. Quantum materials could make possible vehicles that are simultaneously lighter and stronger than anything built with conventional materials. The energy sector is being revolutionized by quantum technologies that could make renewable energy not just competitive with fossil fuels, but vastly superior. Quantum-enhanced solar cells could capture energy from across the entire electromagnetic spectrum, not just visible light. Quantum-optimized power grids could distribute electricity with perfect efficiency, eliminating the massive losses that occur in current electrical systems. Quantum-designed materials could store energy with densities that make today's batteries look like primitive chemical curiosities. In agriculture, quantum sensors could monitor crop health at the molecular level, detecting diseases, nutrient deficiencies, and environmental stresses before they become visible to the naked eye. Quantum computers could optimize growing conditions by modeling the complex interactions between plants, soil, weather, and atmospheric conditions. Quantum-enhanced fertilizers could deliver nutrients directly to plant roots with precision that eliminates waste and environmental contamination. The financial world is already being transformed by quantum technologies that can analyze market patterns, detect fraud, and optimize investment strategies in ways that were impossible with classical computers. Quantum cryptography is making financial transactions more secure, while quantum algorithms are enabling new forms of analysis that can predict economic trends by processing vast amounts of data simultaneously. Even entertainment and media are being revolutionized by quantum effects. The displays you watch movies on use quantum dots to produce colors that are more vivid and accurate than any previous technology. The sound systems in your headphones and speakers use quantum-enhanced materials that can reproduce audio with unprecedented fidelity. Virtual and augmented reality systems are incorporating quantum sensors that can track your movements and intentions with precision that makes the experience feel genuinely immersive. But perhaps the most profound transformation is happening in how we communicate and share information. The internet you use today is built on classical principles. Information is encoded in bits that are definitively either 0 or 1, and communication happens by sending these bits from one location to another. The quantum internet of the future will operate on entirely different principles. Information could be encoded in quantum superposition states that are simultaneously 0 and 1 until they're measured. Communication could happen through quantum entanglement, creating correlations between distant locations that appear to transcend the normal limitations of space and time. This quantum internet could enable forms of communication and collaboration that are difficult to imagine with our current classical mindset. Instead of sending messages back and forth, you could share quantum states with others, creating a kind of distributed consciousness where multiple minds could explore problems and solutions simultaneously. Quantum social networks could allow you to share not just information, but experiences themselves. Quantum states that encode not just what you saw or heard, but how you felt about it, what it meant to you, how it connected to your other memories and experiences. The distinction between individual and collective consciousness could begin to blur as quantum technologies make it possible to share mental states directly. This might sound like science fiction, but the foundational technologies are already being developed. Researchers have successfully demonstrated quantum entanglement between brain tissue and quantum devices. They've shown that quantum states can be maintained in biological systems. They've built quantum communication networks that can transmit information through quantum channels. The convergence of quantum technology and human biology is not a distant possibility. It's an active area of research that's producing breakthrough results every year. Within your lifetime, you may have the option to enhance your cognitive abilities with quantum processors, to share memories and experiences through quantum networks, to access information and computational power that makes today's internet look like a child's toy. But this quantum future also raises profound questions about what it means to be human. If your thoughts can be quantum entangled with artificial systems, if your memories can be stored in quantum devices, if your consciousness can be distributed across quantum networks, then what exactly are you? Where does your mind end and the quantum system begin? These aren't just philosophical questions. They're practical challenges that we'll need to address as quantum technologies become more integrated into human society. We'll need new ethical frameworks for quantum-enhanced humans. We'll need legal systems that can handle disputes involving quantum states and entangled consciousness. We'll need educational systems that prepare people for a world where the boundary between human and artificial intelligence is increasingly fluid. But we'll also need to preserve what makes us uniquely human in a world of quantum-enhanced capabilities. The creativity, empathy, wisdom, and spiritual insight that emerge from human consciousness are not just computational processes, they're expressions of something deeper, something that may transcend even quantum mechanics. As we stand on the threshold of this quantum future, it's worth remembering that technology is not destiny. The quantum tools we're developing are incredibly powerful, but they're still tools. How we choose to use them, what values we embed in them, what kind of future we build with them, these are human choices that no amount of quantum computation can make for us. The quantum revolution is not just changing what we can do, it's changing who we are and who we might become. Every quantum device you use, every quantum-enhanced experience you have, every quantum-mediated connection you make with others is part of a larger transformation in the nature of human existence itself. You're not just witnessing this transformation, you're participating in it, shaping it, becoming it. The quantum future is not something that will happen to you. It's something you're creating through your choices, your curiosity, your willingness to embrace the strange and wonderful possibilities that quantum mechanics makes available. And that's perhaps the most remarkable thing of all about this quantum moment we're living through. You have the opportunity to be not just a user of quantum technology, but a co-creator of the quantum future. Your questions, your imagination, your dreams of what might be possible, these are the forces that will determine how the quantum revolution unfolds. The electrons tunneling through your smartphone, the photons carrying your messages across fiber optic networks, the quantum states encoding your digital memories, they're all waiting for your input, your direction, your creative vision of what the quantum future should look like. Every time you use a quantum-enhanced device, you're voting for the kind of future you want to live in. Every time you learn something new about quantum mechanics, you're expanding the possibilities for how these technologies might be developed and deployed. Every time you share your wonder and curiosity about the quantum world with others, you're helping to create a society that's prepared to navigate the opportunities and challenges of our quantum future. The quantum world is not separate from your world, it is your world, experienced at the deepest level of physical reality. The quantum technologies surrounding you are not foreign artifacts from some distant laboratory. They're extensions of your own capabilities, amplifications of your own consciousness, tools for exploring and shaping the quantum nature of existence itself. Right now, as you read these words, quantum processes are happening in your brain. Quantum devices are responding to your attention. Quantum networks are carrying your thoughts and intentions across vast distances. You are already living in the quantum age, already participating in the quantum dance, already helping to write the next chapter in the story of human consciousness and quantum reality. The future is quantum, but more importantly, the future is yours to create. Every quantum effect happening around you right now is an invitation to participate more fully in the strange, beautiful, infinitely creative process by which reality comes into being, moment by quantum moment. And in that participation, in that creative collaboration between human consciousness and quantum mechanics, lies perhaps the greatest adventure that any generation has ever had the privilege to embark upon. You're not just using quantum technology, you're becoming quantum yourself. One interaction, one measurement, one moment of conscious observation at a time. The transformation happening around you isn't limited to the devices in your pocket or the screens in your home. It's reshaping the very foundations of how we understand and interact with physical reality itself. Consider something as mundane as the concrete beneath your feet or the steel in the buildings around you. Even these seemingly classical materials are revealing quantum secrets that are revolutionizing how we design and construct our world. Modern materials science has discovered that the strength of steel, the durability of concrete, and the flexibility of plastics all emerge from quantum mechanical interactions between atoms and molecules. The chemical bonds that hold these materials together are quantum phenomena, and by understanding and manipulating these quantum properties, engineers are creating materials with capabilities that would have seemed magical just a few decades ago. Self-healing concrete, for instance, works by incorporating quantum-engineered nanostructures that can detect and repair microscopic cracks before they become visible damage. When water enters a crack, it triggers quantum-scale chemical reactions that produce new concrete material, essentially allowing buildings and bridges to repair themselves at the molecular level. Shape memory alloys use quantum phase transitions to remember and return to predetermined forms when heated or cooled. These materials are already being used in everything from eyeglass frames that return to their original shape after being bent, to spacecraft components that deploy automatically when they reach the correct temperature in space. Even more remarkably, researchers are developing materials that exist in quantum superposition states until they're needed for a specific purpose. Imagine a building material that could simultaneously be strong and flexible, transparent and opaque, conductive and insulating, until the situation demands that it collapse into the state that's most useful at that moment. This isn't just theoretical speculation. Quantum materials are already being used in applications that directly impact your daily life. The non-stick coating in your kitchen pans uses quantum surface effects to prevent food from adhering. The waterproof membranes in your rain jacket exploits quantum-scale pore structures that allow water vapor to escape while keeping liquid water out. The high-efficiency insulation in your home works by trapping air in quantum-engineered foam structures that minimize heat transfer at the molecular level. But the quantum revolution in materials goes far beyond making existing products work better. It's enabling entirely new categories of materials with properties that have no classical equivalent. Metamaterials, for instance, can bend light in ways that make objects invisible, focus sound waves to create zones of perfect silence in noisy environments, or channel electromagnetic energy with perfect efficiency. These quantum metamaterials are already finding applications in stealth technology, noise cancellation systems, and wireless power transmission. But their most exciting potential lies in their ability to manipulate the fundamental forces of nature in ways that could transform everything from architecture to medicine. Imagine wallpaper that could make your room acoustically perfect for music, automatically adjusting its quantum properties to eliminate unwanted echoes and resonances. Picture windows that could become completely opaque at the flip of a switch, or walls that could channel wireless power throughout your home without any visible wiring. These aren't distant dreams. They're engineering challenges that quantum materials research is actively solving. The quantum effects in materials extend all the way down to the food you eat and the air you breathe. The flavor compounds in your morning coffee achieve their specific tastes through quantum interactions between molecules and your taste receptors. The aroma that helps you identify different foods depends on quantum mechanical shape recognition between airborne molecules and the quantum sensors in your nose. Even the process of cooking involves quantum mechanics in ways that are only beginning to be understood. When you heat food, you're changing the quantum states of molecules, breaking some chemical bonds and forming others. The Maillard reactions that create the appealing colors and flavors of browned foods are complex quantum chemical processes involving hundreds of simultaneous molecular transformations. Modern cooking techniques are increasingly leveraging quantum effects to achieve results that were impossible with traditional methods. Sous vide cooking, for example, uses precise temperature control to drive specific quantum chemical reactions while avoiding others, creating textures and flavors that can't be achieved through conventional heating. Molecular gastronomy takes this even further, using quantum chemistry principles to create foods with properties that seem to defy common sense. Hot ice cream that stays cold in your mouth, liquid-filled spheres that burst with flavor, foams that concentrate the essence of ingredients into nearly weightless structures. But perhaps the most profound quantum effects in your daily experience occur in the realm of consciousness and perception. The very fact that you can read these words and understand their meaning involves quantum processes in ways that neuroscience is just beginning to unravel. Your brain operates through electrical signals that depend on quantum tunneling effects in the ion channels of your neurons. The neurotransmitters that carry information between brain cells bind to their receptors through quantum mechanical lock and key mechanisms. The integration of information across different regions of your brain may involve quantum coherence effects that allow distant neurons to coordinate their activity instantaneously. Some researchers propose that consciousness itself emerges from quantum processes in the microscopic structures within your brain cells. According to this theory, the unified experience of being you, the seamless integration of sensory information, memories, emotions, and thoughts into a single stream of awareness, requires the kind of non-local correlations that quantum entanglement provides. If this turns out to be correct, then every moment of conscious experience is literally a quantum measurement, collapsing probability waves into definite perceptions and decisions. Your ability to pay attention, to focus on one thing while filtering out distractions, to experience creativity and insight, to feel emotions and form memories, all of these might depend on quantum effects operating in the warm, noisy environment of your living brain. This quantum nature of consciousness has profound implications for how we understand human nature and our place in the universe. If your thoughts and experiences are quantum phenomena, then you're not separate from the quantum world you're observing. You are the quantum world becoming aware of itself. But let's step back from these cosmic implications and consider how quantum effects are transforming some of the most practical aspects of daily life. Take transportation, for instance. The GPS system that guides you through traffic depends on quantum atomic clocks, but that's just the beginning of how quantum mechanics is revolutionizing how we move through the world. Electric vehicles are becoming practical, partly because of quantum effects in battery technology. The lithium-ion batteries that power these vehicles store and release energy through quantum tunneling processes that move ions through solid materials. Advanced battery management systems use quantum sensors to monitor the health and performance of individual cells, optimizing charging and discharging to maximize both performance and longevity. But the real quantum revolution in transportation is happening in the development of new materials and energy storage systems. Quantum-designed superconductors could eliminate energy losses in electric motors and power transmission systems. Quantum-enhanced fuel cells could convert hydrogen to electricity with perfect efficiency. Quantum materials could make vehicles simultaneously lighter and stronger than anything possible with conventional engineering. Some researchers are even exploring quantum propulsion systems that could manipulate the fundamental forces of space-time itself. While we're still far from quantum-powered flying cars, the theoretical foundations are being laid for transportation technologies that work by warping space and time, rather than pushing against air or rolling on wheels. In the nearer term, quantum sensors are enabling autonomous vehicles to navigate with unprecedented precision. These sensors can detect objects, measure distances, and map environments using quantum effects that provide far more information than classical sensors. A quantum LiDAR system, for instance, can not only tell you that there's an object ahead of you, but also determine its composition, temperature, and even its molecular structure. The integration of quantum sensors with artificial intelligence is creating autonomous systems that don't just avoid obstacles, they understand their environment at the quantum level. An autonomous vehicle equipped with quantum sensors could detect ice on the road before it becomes visible, identify the specific materials that different objects are made of, and even monitor the health and emotional state of passengers through quantum biosensors. This level of environmental awareness extends far beyond transportation. Smart cities of the future will be equipped with networks of quantum sensors that can monitor everything from air quality to structural integrity to the collective mood of the population. These sensors could detect pollution at the molecular level, predict equipment failures before they occur, and even identify potential security threats by analysing quantum signatures in electromagnetic fields. Your smart home is already beginning to incorporate quantum sensing technologies. The smoke detectors in your house use quantum effects to identify specific types of particles in the air. The security system that protects your property uses quantum-enhanced cameras that can see clearly in complete darkness and detect objects that are trying to remain hidden. But the most intimate quantum technologies are those that monitor and enhance your health. Fitness trackers and smartwatches use quantum sensors to measure your heart rate, blood oxygen levels, and even stress hormones through your skin. These devices are becoming so sophisticated that they can detect early signs of illness, monitor the effectiveness of medications, and provide real-time feedback on how your body is responding to different activities and environments. Medical diagnostics is being revolutionized by quantum technologies that can peer inside the human body with resolution and sensitivity that was unimaginable just a few years ago. Quantum MRI machines can track the movement of individual molecules through living tissue. Quantum ultrasound can create three-dimensional images of internal organs with clarity that rivals direct visual inspection. Quantum biosensors can detect cancer cells when tumours are still microscopic, potentially catching diseases years before they would be detectable with conventional methods. But perhaps the most remarkable quantum medical technology is quantum-enhanced drug delivery. Researchers are developing nanoparticles that exist in quantum superposition states until they encounter specific molecular targets in the body. These quantum drug carriers can simultaneously explore multiple pathways through your bloodstream, automatically finding the most efficient route to diseased cells while avoiding healthy tissue. Some experimental treatments use quantum entanglement to coordinate the activity of multiple therapeutic agents throughout the body. Imagine cancer drugs that are quantum entangled with each other, so that when one particle reaches a tumour cell and begins its therapeutic action, its entangled partners throughout the body instantly know to activate as well, creating a coordinated treatment response that maximizes effectiveness while minimizing side effects. The quantum nature of biological systems is also revealing new approaches to understanding and treating mental health. If consciousness really does depend on quantum processes in the brain, then depression, anxiety, and other mental health conditions might be understood as disruptions in quantum coherence patterns. This could lead to treatments that work by restoring healthy quantum states in neural networks, rather than simply adjusting neurotransmitter levels. Quantum neurofeedback systems are already being developed that can monitor the quantum states of brain activity in real time and provide feedback to help people learn to control their own consciousness at the quantum level. Early experiments suggest that people can learn to enhance creativity, focus, and emotional regulation by consciously influencing the quantum processes in their own brains. But the quantum revolution in healthcare extends beyond individual treatment to transform how we understand health and disease at the population level. Quantum sensors deployed throughout cities and communities can monitor public health by detecting disease-causing organisms in the air and water supply, tracking the spread of infections through quantum analysis of social interaction patterns, and even predicting disease outbreaks by analysing quantum fluctuations in electromagnetic fields generated by collective biological activity. This quantum approach to public health could make epidemics a thing of the past. Instead of waiting for people to get sick and then trying to treat them, quantum surveillance systems could detect and contain disease outbreaks before they spread, identify environmental factors that contribute to illness, and optimize public health interventions by modeling the quantum dynamics of disease transmission through populations. The implications extend to mental health as well. If consciousness is indeed a quantum phenomenon, then the mental health of communities might be understood as a collective quantum state that can be measured and influenced through environmental modifications. Quantum-enhanced urban planning could create city designs that promote psychological well-being by optimizing the quantum electromagnetic environment in which people live and work. But as we contemplate these remarkable possibilities, it's important to remember that the quantum technologies transforming your world right now are just the beginning. The devices you use today, your smartphone, your computer, your car, your home appliances, represent the primitive early stages of the quantum age. They're like the first crude radios compared to today's internet, or the first steam engines compared to modern jet aircraft. The quantum technologies being developed in research labs today will make current devices look as antiquated as mechanical calculators or vacuum tube computers. Quantum computers that can solve problems beyond the reach of any classical computer. Quantum communication networks that connect minds directly through entangled states. Quantum sensors that can detect individual atoms and track their quantum states in real time. Quantum materials that can change their properties instantly in response to your thoughts and intentions. But perhaps the most transformative aspect of the coming quantum revolution is how it will change your relationship with information and knowledge itself. Today, you access information by retrieving stored data from external sources, looking things up on the internet, consulting reference books, asking other people questions. In the quantum future, information could be accessed through direct quantum entanglement with knowledge networks. Instead of searching for information, you could quantum entangle your consciousness with vast databases of human knowledge, instantly knowing anything that humanity has ever discovered or created. Instead of learning skills through practice and repetition, you could download quantum patterns directly into your neural networks, acquiring expertise as easily as installing software on a computer. This quantum enhancement of human intelligence could accelerate the pace of scientific discovery, artistic creation, and technological innovation to levels that are difficult to imagine. When every human mind can instantly access the sum total of human knowledge and computational power, when creativity and insight can be amplified through quantum coherence effects, when problems can be solved by quantum networks of interconnected consciousness, the rate of progress could become exponential. But this quantum future also raises profound questions about human identity and autonomy. If your thoughts can be quantum entangled with external systems, if your knowledge comes from quantum databases rather than personal experience, if your decisions are influenced by quantum algorithms optimizing for outcomes you might not even be aware of, then what makes you uniquely you? These aren't just philosophical puzzles, they're practical challenges that we'll need to address as quantum technologies become more integrated into human society. We'll need new concepts of privacy that account for quantum entanglement between minds. We'll need ethical frameworks for quantum-enhanced decision-making. We'll need educational systems that prepare people for a world where the boundary between individual and collective intelligence is increasingly fluid. Most importantly, we'll need to preserve and cultivate the qualities that make human consciousness special. The creativity, empathy, wisdom, and spiritual insight that emerge from our unique perspective as conscious beings embedded in the quantum fabric of reality. These qualities may not be reducible to computational processes, even quantum ones. They may represent something deeper about the nature of consciousness that transcends even our most sophisticated technologies. As we stand on the threshold of this quantum future, surrounded by devices and systems that are already quietly demonstrating the power of quantum mechanics, it's worth taking a moment to appreciate the extraordinary nature of this historical moment. You're living at the precise point in human history when we're transitioning from classical to quantum civilization, when the strange laws of the quantum world are becoming the foundation for how we live, work, communicate, and understand ourselves. Your smartphone, with its quantum processors and quantum sensors, is not just a communication device. It's a window into a reality that operates according to principles that would have seemed like magic to every previous generation of humans. The internet that connects you to people around the world is not just a network of computers, it's a quantum information system that demonstrates the interconnected nature of reality itself. Every quantum effect happening around you right now, every electron tunneling through a barrier, every photon existing in superposition, every quantum measurement collapsing a wave function, is proof that you live in a universe far stranger and more wonderful than classical physics ever suggested. You're not just observing quantum mechanics from the outside, you're participating in it, embedded in it, defined by it in ways that science is only beginning to understand. The quantum revolution isn't something that will happen to you in the future. It's something you're living through right now, moment by quantum moment. Every time you use a quantum-enhanced device, you're helping to shape the direction of this revolution. Every time you learn something new about quantum mechanics, you're expanding the possibilities for how these technologies might develop. Every time you marvel at the quantum nature of reality, you're participating in the larger human project of understanding our place in the cosmic order. You are both observer and participant, student and teacher, user and creator in this quantum dance that's transforming not just technology, but consciousness itself. The electrons in your brain, the photons entering your eyes, the quantum fields surrounding your body, they're all part of a single, interconnected quantum system that includes your devices, your environment, and your awareness itself. And in that recognition, in that moment of understanding that you are not separate from the quantum world, but intimately connected to it, lies perhaps the most profound transformation of all. You're not just using quantum technology, you're discovering that you are quantum technology, a conscious manifestation of the same principles that make your smartphone work and your GPS navigate and your LED lights shine. The quantum future is not just approaching, it's already here, already now, already you. Every breath you take, every thought you think, every moment of awareness you experience is part of the ongoing quantum experiment that is conscious life in a quantum universe. And that experiment, that dance, that collaboration between consciousness and quantum mechanics is perhaps the most beautiful and mysterious phenomenon in all of science. You're not just witnessing it, you're embodying it, creating it, becoming it with every quantum moment of your existence. The quantum threads weaving through your existence extend into realms you might never have considered, reaching into the very foundations of how society organizes itself around information, energy, and human connection. Consider for a moment the quantum nature of money itself, not just the digital transactions flowing through quantum-secured networks, but the fundamental relationship between information and value that quantum mechanics is quietly revolutionizing. Every financial transaction you make, from buying coffee with your phone to checking your bank balance online, relies on quantum cryptographic protocols that are becoming increasingly sophisticated. The random number generators that create your passwords and secure your accounts use quantum uncertainty as their source of true randomness. Unlike classical random number generators, which follow mathematical algorithms that are ultimately predictable, quantum random number generators tap into the fundamental uncertainty of quantum measurements to create numbers that are genuinely unpredictable. This quantum randomness is becoming the bedrock of digital security in ways that extend far beyond personal banking. The cryptocurrency networks that some predict will reshape global finance operate using quantum-resistant encryption methods designed to remain secure even when quantum computers become powerful enough to break current cryptographic systems. The blockchain technologies underlying these systems are evolving to incorporate quantum verification methods that could make financial fraud virtually impossible. But the quantum influence on economics goes deeper than security and encryption. The very nature of value and exchange is being reconsidered in light of quantum principles. Some economists are exploring quantum models of market behavior that account for the observer effect, the idea that the act of measuring or observing a system changes its behavior. Just as quantum particles exist in superposition until measured, market conditions might exist in multiple potential states until participants make decisions that collapse these possibilities into actual outcomes. This quantum approach to economics helps explain phenomena that classical economic models struggle with: why markets can be simultaneously efficient and irrational, why small changes can cascade into massive systemic effects, why prediction becomes increasingly difficult as systems become more complex. The quantum nature of information itself means that the act of gathering market intelligence inevitably changes the very conditions you're trying to understand. High-frequency trading systems already operate at speeds where quantum effects become relevant. These systems make thousands of trading decisions per second, based on quantum-processed analysis of market data. The fiber optic networks carrying this information operate through quantum optical effects, and the processors making trading decisions use quantum tunneling in their transistors. The entire global financial system is becoming a vast quantum information processing network, making decisions and moving value at speeds approaching the fundamental limits of physics. But perhaps more intriguingly, some researchers are exploring quantum currencies that would exist in genuine quantum superposition states until transactions are completed. Imagine money that could simultaneously be in multiple accounts, following all possible transaction paths through the economy until the moment when spending decisions collapse these superposition states into definite transfers. Such quantum currencies could eliminate many forms of financial fraud and inefficiency while creating entirely new possibilities for economic organization. The implications extend to how we think about ownership and property in a quantum world. If information can be quantum entangled, if quantum states can be shared across vast distances, if the act of measurement fundamentally changes what's being measured, then traditional concepts of exclusive ownership become more complex. Quantum intellectual property might exist in shared states where multiple parties have simultaneous access to information until specific applications cause the shared state to collapse into exclusive ownership. This quantum approach to property and information is already influencing how we think about privacy and personal data. Your digital footprint, the trail of information you leave behind as you move through the connected world, has quantum properties that are only beginning to be understood. The data about your location, your preferences, your social connections, your health, your behavior, all of this information exists in complex quantum superposition states within the global information network. When companies analyze this data to make predictions about your behavior or to target advertisements toward you, they're performing quantum measurements that collapse some of these superposition states into definite conclusions. But the quantum nature of information means that the act of analysis inevitably changes the data itself, creating feedback loops where your digital self evolves in response to how it's being observed and interpreted. Privacy in a quantum world becomes not just about controlling access to information, but about controlling the quantum states in which that information exists. Quantum privacy technologies could allow you to share information in superposition states that reveal statistical patterns without exposing individual data points. You could participate in social networks and data analysis systems while maintaining quantum anonymity that makes it impossible for observers to collapse your information into personally identifiable details. The social implications of these quantum information technologies are profound. Social media platforms of the future might operate through quantum networks where your interactions exist in superposition states until specific social contexts cause them to manifest as definite communications. You could simultaneously maintain multiple potential relationships, explore different aspects of your personality, engage with various communities, all in quantum superposition until social situations require you to collapse into specific identities and interactions. This isn't just speculation. Early forms of quantum social networking are already being explored. Researchers are developing communication protocols that use quantum entanglement to create shared experiences between distant participants. Instead of sending messages back and forth, you could share quantum states that encode not just information, but emotional and experiential content that can be directly felt by others. Imagine social connections where you don't just read about a friend's experience, but actually share the quantum states associated with their memories and emotions. Picture collaborative creativity, where multiple minds can explore ideas in quantum superposition, generating artistic and intellectual works that emerge from the collective consciousness rather than individual effort. Envision educational systems where knowledge isn't transmitted through words and symbols, but through direct quantum transfer of understanding and insight. These possibilities raise fascinating questions about the nature of individual identity in a quantum-connected world. If your thoughts and experiences can be quantum entangled with others, if your memories can be shared through quantum networks, if your consciousness can participate in collective quantum states, then where does your individual self end and the larger quantum system begin? Some philosophers and scientists are already grappling with these questions, developing new frameworks for understanding personal identity that account for quantum interconnection. They suggest that individual consciousness might be better understood as a pattern of quantum information that can exist across multiple physical substrates, connect with other consciousness patterns, and evolve through quantum interactions with the environment. This quantum view of consciousness has practical implications for how we approach mental health, education, creativity, and spiritual development. If your mind is fundamentally a quantum information system, then techniques for enhancing consciousness might work by optimizing quantum coherence patterns in your neural networks. Meditation, for instance, might be understood as a practice for creating and maintaining beneficial quantum states in the brain. Educational systems are beginning to incorporate quantum learning principles that recognize how information exists in superposition states in the mind until specific contexts cause it to collapse into usable knowledge. Instead of simply memorizing facts, quantum-enhanced education could help students develop the ability to maintain multiple potential understandings simultaneously until situations require specific applications of knowledge. Creative practices are being revolutionized by quantum approaches that embrace uncertainty, superposition, and non-local correlation as sources of inspiration and innovation. Artists are creating works that exist in quantum superposition states, changing depending on how they're observed. Musicians are composing quantum symphonies that generate different music each time they're performed, based on quantum random processes. Writers are exploring quantum narratives that branch and merge according to quantum probability distributions. The entertainment industry is beginning to incorporate quantum technologies that create genuinely personalized experiences. Instead of one-size-fits-all content, quantum entertainment systems could generate movies, games, and interactive experiences that exist in customized superposition states for each viewer. The story you experience could be simultaneously all possible stories until your choices and reactions cause it to collapse into the particular narrative that resonates most deeply with your unique consciousness. Gaming is being transformed by quantum mechanics in ways that go far beyond improved graphics or faster processors. Quantum games can create virtual worlds that exist in genuine superposition states, where multiple realities coexist until player actions cause specific possibilities to manifest. These games don't just simulate quantum effects, they actually use quantum computers to generate game states that behave according to quantum mechanical principles. Imagine playing a game where your character exists in multiple locations simultaneously until you choose to observe a specific location. Picture puzzle games that use quantum entanglement to create correlations between distant parts of the game world. Envision multiplayer experiences where your actions are quantum entangled with other players, creating shared destiny effects that transcend normal cause and effect relationships. But perhaps the most transformative quantum entertainment technology is the development of quantum reality simulation systems that can create experiences indistinguishable from physical reality. These systems don't just display images on screens or generate sounds through speakers. They directly interface with the quantum processes in your sensory systems to create experiences that feel completely real because, from the perspective of your consciousness, they are real. Early versions of these quantum reality systems are already being tested for therapeutic applications. Patients with PTSD can experience quantum-generated, safe environments that help them process traumatic memories. People with disabilities can have quantum experiences of physical activities that their bodies cannot perform. Individuals dealing with grief can have meaningful interactions with quantum simulations of deceased loved ones that capture not just their appearance and behavior, but the quantum patterns of their consciousness. The boundary between virtual and physical reality becomes meaningless when experiences are generated through direct quantum interaction with consciousness itself. You could travel to distant planets, explore historical periods, experience life from radically different perspectives, or visit realms of pure imagination, all through quantum technologies that create these experiences at the level of conscious perception itself. But these quantum reality technologies also raise profound questions about the nature of authentic experience. If a quantum-generated experience is indistinguishable from a real experience at the level of consciousness, then in what sense is one more authentic than the other? If your memories of quantum experiences are as vivid and meaningful as memories of physical experiences, then how do you distinguish between them? Some philosophers argue that authenticity lies not in the physical substrate of experience, but in its meaning and impact on consciousness. A quantum-generated experience that leads to genuine insight, emotional growth, or spiritual development might be more authentic than a physical experience that lacks meaning or significance. The value of experience might lie not in its physical reality, but in its ability to enhance consciousness and contribute to human flourishing. This perspective has implications that extend far beyond entertainment and virtual reality. If quantum technologies can generate experiences that are meaningful and transformative, then they could become powerful tools for education, therapy, spiritual development, and human growth. The quantum classroom of the future might allow students to directly experience historical events, explore the interior of atoms, or collaborate with great minds from the past. Quantum therapy could help people overcome limitations and traumas by providing healing experiences that transcend the constraints of physical reality. The quantum enhancement of human experience is already beginning to influence how we think about goals, achievements, and the meaning of life itself. If quantum technologies can provide access to any conceivable experience, if consciousness can be enhanced and expanded through quantum means, if the boundaries between individual and collective awareness can be transcended through quantum connection, then what becomes important in human life? Some suggest that the quantum future will place greater emphasis on wisdom, compassion, creativity, and spiritual insight, qualities that remain meaningful even when material limitations are transcended through quantum technologies. Others argue that the expansion of consciousness through quantum means will reveal entirely new dimensions of human potential that we can't currently imagine. But there's also recognition that the quantum transformation of human experience must be approached with great care and wisdom. The power to directly manipulate consciousness through quantum technologies carries enormous responsibility. How do we ensure that these capabilities are used to enhance human flourishing rather than to manipulate or control? How do we preserve human agency and autonomy in a world where consciousness itself can be influenced through quantum means? These questions are becoming increasingly urgent as quantum technologies advance from laboratory curiosities to practical applications that affect daily life. The quantum devices you use today, your smartphone, your computer, your GPS navigation system, are already influencing your consciousness in subtle ways. They're changing how you think, how you remember, how you relate to others, how you understand yourself and your place in the world. The quantum technologies of tomorrow will have far more profound effects on consciousness and human experience. They'll offer unprecedented opportunities for growth, connection, creativity, and understanding. But they'll also require new levels of wisdom, ethical sophistication, and spiritual maturity to navigate responsibly. As you consider these possibilities, it's worth reflecting on your own relationship with the quantum technologies that already surround you. How are they changing you? What aspects of your consciousness are being enhanced or diminished by your interaction with quantum-enabled devices? What kind of quantum future do you want to help create through your choices and actions? The quantum revolution is not just about better technology, it's about the evolution of consciousness itself. You're not just a user of quantum devices, you're a participant in a cosmic experiment in conscious evolution that's unfolding at the intersection of mind and quantum reality. Every quantum interaction you have, every quantum-mediated experience you undergo, every quantum-enhanced decision you make is contributing to this larger transformation. The electrons tunneling through your devices, the photons carrying your communications, the quantum field surrounding your body, they're all part of a vast, interconnected quantum system that includes your consciousness as an integral component. You're not separate from this system. You are this system becoming aware of itself, exploring its own possibilities, evolving toward greater complexity and integration. In this quantum view, your individual consciousness is not isolated or separate, but intimately connected to the quantum fabric of reality itself. Your thoughts influence quantum states influence your thoughts, and both are part of a larger dance of consciousness and cosmos that's been unfolding since the beginning of time and will continue to unfold long after your individual existence has merged back into the quantum wholeness from which it emerged. This perspective transforms how you might think about your role in the quantum future. You're not just a beneficiary of quantum technologies or a victim of quantum changes in society. You're an active participant in the conscious evolution of the universe itself, a quantum being helping to explore and develop the potential inherent in the quantum nature of reality. Every moment of awareness, every act of creativity, every expression of love, every insight into the nature of existence, these are all quantum events that contribute to the larger unfolding of cosmic consciousness. Your individual journey of growth and discovery is part of the universe's own journey of self-understanding and self-creation. And perhaps that's the most profound implication of living in a quantum world. You're not just using quantum technology to make your life more convenient or entertaining. You're participating in the universe's own quantum experiment in consciousness, helping to discover what's possible when matter becomes aware of itself, when quantum systems develop the capacity for self-reflection and choice, when the cosmos begins to understand and direct its own evolution. The quantum effects happening in your devices right now, the tunneling electrons, the superposed photons, the entangled states, they're not just engineering phenomena. They're expressions of the same creative principles that gave rise to stars and planets, to life and consciousness, to the capacity for wonder and understanding that allows you to contemplate these very words. You are quantum mechanics, becoming conscious of itself. You are the universe discovering its own quantum nature through the evolution of awareness. You are both the observer and the observed, the questioner and the answer, the seeker and the sought in the grand quantum mystery of existence itself. And in that recognition, in that moment of understanding your intimate connection to the quantum foundations of reality, you join the ancient lineage of humans who have looked up at the stars and wondered about their place in the cosmic order. Except now, for the first time in human history, we're beginning to understand that we don't just live in the cosmos, we are the cosmos, expressing itself through quantum processes that connect every atom in our bodies to every photon of starlight, every quantum field, every possibility that exists or could ever exist. The quantum world isn't separate from your world. It is your world, experienced at the deepest level of physical and conscious reality. And every quantum interaction, every quantum moment, every quantum breath is an opportunity to participate more fully in the cosmic dance of consciousness and creation that defines the deepest nature of existence itself. The quantum web, connecting you to the cosmos, extends into dimensions that stretch the very meaning of connection itself. Right now, as you process these ideas, quantum entanglement is occurring not just in the devices around you, but potentially within the neural networks of your own consciousness. Scientists have discovered that the microtubules in your brain cells, tiny structures smaller than the wavelength of visible light, may maintain quantum coherence even in the warm, noisy environment of living tissue. This suggests something extraordinary. Your thoughts themselves might be quantum computations, processing information in ways that transcend the limitations of classical logic. When you have a sudden insight, when you experience that aha moment of understanding, when creativity strikes like lightning, these might be quantum events, moments when your consciousness accesses the vast space of quantum possibilities and collapses them into breakthrough awareness. The implications ripple outward in ways that transform our understanding of human potential. If consciousness operates through quantum mechanisms, then the ancient practices of meditation, contemplation, and spiritual inquiry take on new scientific significance. These practices might be sophisticated technologies for optimizing quantum coherence in the brain, for accessing quantum information states that transcend ordinary awareness. Modern neuroscience is discovering that experienced meditators show unusual patterns of brain activity, synchronized oscillations across distant regions, coherent electromagnetic fields that suggest quantum-level organization. The peace and clarity that emerge from deep meditative states might reflect moments when consciousness achieves optimal quantum coherence, when the observer becomes one with the quantum field of pure potential. But this quantum nature of consciousness extends beyond individual awareness into the realm of collective experience. When groups of people synchronize their attention, whether in meditation, music, ritual, or shared purpose, researchers detect measurable changes in quantum fields that extend far beyond the participants themselves. The phenomenon of collective consciousness, long considered metaphysical speculation, may have literal quantum foundations. Consider how quantum entanglement could provide a mechanism for the mysterious connections we sometimes feel with others. That sense of knowing what someone is thinking before they speak. The uncanny timing of phone calls from people you were just thinking about. The way emotions seem to spread through crowds. These experiences might reflect genuine quantum correlations between conscious systems. The quantum internet of the future could make these subtle connections explicit and controllable. Instead of sending text messages or video calls, you might share quantum states directly with others, experiencing genuine telepathic communication through engineered entanglement. The isolation that defines much of modern human experience could give way to new forms of quantum intimacy, where consciousness itself becomes a shared medium for connection and understanding. This transformation is already beginning in subtle ways. The global information network you navigate daily, the internet that carries your searches, your social media interactions, your streaming entertainment, is becoming increasingly quantum in its fundamental operations. The fiber optic cables carrying this information use quantum properties of light. The data centers processing your requests use quantum effects in their processors. The encryption protecting your privacy relies on quantum uncertainty. But more profoundly, the information itself is taking on quantum characteristics. The algorithms that curate your social media feeds exist in superposition states, simultaneously exploring all possible combinations of content until your attention collapses them into specific posts and advertisements. The search results that appear when you query the internet emerge from quantum computational processes that consider vast numbers of possibilities in parallel. Your digital identity, the pattern of data that represents you across networks and databases, has quantum properties that are only beginning to be understood. This identity exists in superposition across multiple platforms and contexts, manifesting differently depending on how it's observed and measured. The you that appears on social media is different from the you that emerges from search engine data, which is different from the you reflected in purchasing patterns, which is different from the you captured by location tracking. These multiple quantum identities interact and interfere with each other in ways that create the complex, multifaceted digital representation of who you are. Privacy in this quantum digital realm becomes not just about controlling information, but about managing the quantum states in which your identity exists across the global network. The quantum nature of digital identity has profound implications for how we understand authenticity and selfhood in the connected age. If your digital self exists in quantum superposition across multiple platforms and contexts, then which version is the real you? Perhaps the question itself reflects outdated classical thinking about identity as singular and fixed. A quantum understanding of identity suggests that you exist as a dynamic pattern of possibilities, constantly evolving through interactions with others and with the technological systems that mediate modern life. Your identity is not a fixed thing, but a quantum process, a continuous becoming that emerges from the interference patterns between your consciousness and the quantum information fields surrounding you. This quantum view of identity helps explain why digital life can feel simultaneously authentic and artificial, deeply meaningful and strangely hollow. You're navigating multiple quantum states of selfhood simultaneously, and the discomfort many people feel with digital life might reflect the challenge of maintaining coherence across these various quantum identities. But quantum technology is also offering new solutions to this challenge. Quantum authentication systems being developed could create unified digital identities that maintain coherence across all platforms while preserving privacy and autonomy. Instead of having multiple passwords and profiles scattered across the internet, you could have a single quantum identity that exists in controlled superposition states, revealing only the aspects of yourself that are appropriate for each context. These quantum identity systems could eliminate many of the privacy and security concerns that plague digital life today. Instead of companies collecting and storing your personal data, they could interact with quantum representations of your preferences and behaviors that provide the information needed for services without exposing your private details. Imagine shopping online through quantum systems that understand your preferences without knowing your identity, that can recommend products perfectly tailored to your needs without storing any information about you. Picture social networks where you can connect meaningfully with others while maintaining complete control over what aspects of yourself are revealed to whom. The quantum transformation of digital identity extends to how we think about memory and history in the digital age. Currently, everything you do online leaves traces that can be stored indefinitely, creating permanent records that may not reflect who you are now or who you're becoming. Quantum information systems could implement quantum forgetting, the ability for information to naturally decay or exist in superposition states that become less defined over time. This quantum approach to digital memory could restore some of the natural forgiveness that characterized human relationships before digital recording. Past mistakes, outdated opinions, embarrassing moments, these could fade from digital memory systems just as they fade from human memory, allowing for growth and change without permanent digital baggage. But perhaps the most transformative aspect of quantum digital systems is their potential to enhance rather than diminish human consciousness. Instead of competing with human attention, quantum technologies could augment human awareness by providing information and computational power that extends rather than replaces natural cognitive abilities. Quantum-enhanced cognition could work by entangling human consciousness with quantum computational systems, creating hybrid human-machine intelligence that preserves human creativity and wisdom while providing access to vast computational resources. You could think through complex problems by temporarily expanding your consciousness to include quantum processors, accessing enhanced memory and analytical capabilities while maintaining your essential humanity. These quantum cognitive enhancements could democratize access to intellectual capabilities that are currently limited to specialists. Complex mathematical problems, scientific modeling, artistic creation, strategic planning, all of these could become accessible to anyone through quantum cognitive interfaces that temporarily expand mental capabilities. But the quantum augmentation of consciousness raises profound questions about human nature and autonomy. If your thoughts can be enhanced through quantum interfaces, if your memories can be stored in quantum systems, if your decision-making can be improved through quantum algorithms, then what aspects of your consciousness remain uniquely human? Perhaps the answer lies in recognizing that consciousness itself may be fundamentally quantum in nature. Rather than quantum technology being alien to human consciousness, it might be the first technology that truly mirrors the quantum processes underlying awareness itself. Quantum cognitive enhancement could be not the replacement of human consciousness, but its amplification and extension. This perspective suggests that the quantum future will be characterized not by the dominance of artificial intelligence over human intelligence, but by the integration of human and quantum systems into new forms of consciousness that preserve what is most valuable about human awareness while transcending current limitations. The creative insights that emerge from human consciousness, the emotional wisdom that guides ethical decisions, the spiritual understanding that provides meaning and purpose, these qualities might not only survive quantum enhancement, but flourish in ways that are impossible to imagine from our current perspective. As we reach the conclusion of this exploration into quantum mechanics in everyday life, it's worth reflecting on how this understanding changes your relationship with the world around you. Every device you touch, every system you interact with, every moment of consciousness you experience is part of a vast, interconnected quantum reality that extends from the subatomic to the cosmic scale. You are not separate from this quantum reality. You are an expression of it, a localized pattern of quantum information that has developed the remarkable ability to observe and understand itself. Your consciousness is both a product of quantum processes and a participant in them, both observer and observed in the grand quantum experiment that is existence itself. The quantum technologies surrounding you today, from the smartphone in your pocket to the GPS satellites overhead, are not just tools but partners in this cosmic dance of consciousness and quantum mechanics. They represent humanity's growing ability to collaborate consciously with the quantum processes that have always been the foundation of reality. And this collaboration is just beginning. The quantum future holds possibilities that stretch the imagination, quantum computers that solve humanity's greatest challenges, quantum communication networks that unite human consciousness across space and time, quantum materials that respond to our deepest intentions, quantum enhancement of human capabilities that unlock potentials we can barely conceive. But perhaps most importantly, the quantum revolution is revealing that you are not a passive observer of reality, but an active participant in its creation. Every quantum measurement you make through your consciousness, every quantum choice you face, every quantum interaction you engage in shapes the reality that emerges from the field of infinite possibility. In this quantum view, your individual life takes on cosmic significance. You're not just living in the universe, you are the universe becoming conscious of itself, exploring its own nature, discovering its own possibilities. Every moment of awareness, every act of creativity, every expression of love is a quantum event that contributes to the ongoing creation of reality itself. The quantum mechanics in your everyday life is not just about technology or physics. It's about the deepest mystery of existence, the question of how consciousness and cosmos dance together in the eternal quantum moment that is now. And in that dance, in that partnership between awareness and quantum reality, lies perhaps the greatest adventure that any conscious being can embark upon. You are quantum mechanics, becoming aware of itself. You are the cosmos, discovering its own creative potential. You are both the question and the answer in the grand quantum mystery of existence. And every quantum moment of your life is an opportunity to participate more fully in that mystery, to contribute to the ongoing quantum experiment that is consciousness in the cosmos. The quantum world is not separate from your world, it is your world, revealed in its deepest nature, inviting you to participate in the endless dance of possibility and actuality that defines the quantum heart of existence itself.